And geometry, here we go with chapter 10, section 1, part 2. So we just finished this last example right here, in fact 3 examples, where we were talking about the area of a parallelogram being base times height. Moving on to part 2 of this section, we're going to talk now about areas of triangles, and this formula is only slightly different than what we were talking about here before. The area of a triangle, everybody, is given to us by this formula right over here, 1/2 times base times height. Now in trying to figure out where that formula comes from, it deals with the concept right here that, oh wait a minute, I don't think I know how to do this on the iPad right here. Can I do, no, copy? I'm looking for duplicate and that's not quite here, but what if I copied this thing and then pasted it right down here? Yeah, okay, that worked. So you'll notice here, right next to it, I've got another triangle now that's identical to the one that we just started with. Well, if we take this triangle and we rotate it around 180 degrees, again, the area of it has not changed, and we move this right back over here, now if we take a look at the larger outer figure here, everybody, we have ourselves a quadrilateral with what certainly appears to be 2 pairs of parallel sides, and we could prove that if we were so inclined, but I think we'll assume that for now. The top and bottom are parallel, the left and the right are parallel. We can see that this big quadrilateral right here is in fact a parallelogram, and therefore the area of that entire parallelogram, which we just got done talking about earlier, is base times height, base being this piece down here on the bottom and the height being this vertical piece, which of course is perpendicular to it. That's the key. Well, the triangle that we started with, the original triangle I should say, was just half of that parallelogram that we ended up with. So if we wanted the area of just the triangle, it would be 1/2 of this area measurement which we came up with right here. So by putting a 1/2 in front of that or dividing it by 2, we ended up with this formula right here. You will also see this formula expressed sometimes as base times height divided by 2. But hey, you're big kids and you know that multiplying by 1/2, like we did right here, is the same thing as dividing by 2, which we did right here. So there's our formula for area of a triangle. All right, a couple quick examples, but none of this is going to tax you guys all that much, I don't think. All right, so we have ourselves a triangle here in blue, and we're going to try to come up with the area of that triangle. So step 1, let's write out our formula. Area of a triangle is always going to be 1/2 times your base times your height. Step 2, let's fill in what we know. Area of a triangle is going to be 1/2. The base, we would like to think that's always going to be on the bottom right here. Now, this is not my best diagram ever. You might have some confusion about where this 20 actually ends. It looks pretty clear that it goes that far. Now, the question is, does it end right here? Or does it go all the way out here to this point on the left? Well, kind of looking at where it's at in terms of its centering, that 20 was supposed to go all the way out here. So 20 is going to be the length of your base. The height, though, and I'm hoping this sank in from the last section right here, the height always needs to be measured perpendicular to your base. So since we have a right angle here, this dashed line here, that auxiliary line, that altitude, becomes the height of our triangle. And sure enough, that's one piece that we weren't given. So we've got a little bit of figuring that we've got to do on this one right here. So let's get to work on this. And as is often the case, a lot of the trigonometry that we learned back in chapter 8 is going to come into to apply here. So let's talk about why that is. Okay, the entire bottom side of this triangle is 20, and this little piece right over here is 5. Subtracting that 5 from the 20, we see that this side right here, everybody, from there to there, is going to have a length of 15. And now if we take a look at this right triangle right over here, we know 2 of the 3 side lengths within that right triangle. We can see here that we have a hypotenuse of 17 and a leg of 15. So what can we use to find the third side in a right triangle when the other 2 are known? We can use the Pythagorean theorem. Or, I don't know, if we listen to Mr. Fontana when he said it 15,000 times, we could learn our Pythagorean triples, and that would actually make our lives a lot easier. And the fourth of the 5 Pythagorean triples that I asked you guys to memorize was an 8, 15, 17 Pythagorean triple. So there's your 17 for your hypotenuse, there's your 15 for your leg. That tells us that this h right over here would have to have a length of 8. If you want to waste your time and go ahead and do leg squared plus leg squared equals hypotenuse squared, go right ahead. I guarantee you you're going to end up with that same piece right there. So Back to the formula right here, which is kind of our roadmap to kind of keep us in line here. We were looking for the height, and we now know that the height of this triangle is going to be 8 units. So we can go to our calculator and dump all this in. I'd probably just do this one in order, guys. The 1/2 right here is going to get multiplied by the 20 to make a 10, and the 10 times 8 is going to give us 80. Now, I did not give you guys any units in this problem. We don't know if we're talking about inches or millimeters or miles or whatever. So in a problem like that, we use a generic U for units, but because it's area, those units are still going to be squared. So 80 square units is our area of this triangle in example A. Let's move on to example B here, and that's actually the last one that we have to do. Okay, have ourselves a triangle here in black. So let's start with a formula before we think too hard. Area of a triangle is still going to be a 1/2 times a base times a height. Let's fill in what we know. Area of that triangle is going to be a 1/2. Now again, the base of that figure, I see something on the bottom. I know the length of that piece right there, so I'm going to say that 40 inches is going to serve as our base. And now we need to figure out the height of that. Well, there's nothing within the triangle in black that's actually perpendicular to that 40, but they extended that 40 out here to the right with an auxiliary line. They gave us a right angle right here, and that means that this side over here on the right-hand side of that figure, that's our height. And that's what we need to figure out to put into this set of parentheses right over here before we can figure out the area of that triangle. And to do this one, it's kind of the opposite direction of what we did on the last one. We want to take advantage of the fact that we've got our right angle here in the corner, so we want to look at this large outer triangle right here, which I'm highlighting in yellow. And what we can see when we look at that is that we have a hypotenuse of 50 within that triangle right there. And when we put together the 40 and the 8 here on the bottom, we can see that we end up with 48 inches for the length of the entire bottom side. And now we need to figure out H. All right, once again now we have a right triangle. We know 2 sides within that right triangle, so we could do the Pythagorean theorem. Or we could try one more time to think about Pythagorean triples. So I'm going to make this really, really big so it's easy to see here, everybody. All right, so in this side we had a 50 right over here. We had a 48 down on the bottom, and we were trying to come up with an H over here on the right. Okay, so the method that I gave you guys a long time ago for Pythagorean triples, first, take a look for a common factor between 50 and 48. Now, if you notice, those numbers are only 2 apart. That means that 2 is the greatest common factor right here that it could be. Let's divide out that 2 from both of those numbers right there. And when we divide the 2 out from 48, we're going to get a 24 right here. Dividing a 2 from 50 is going to give us a 25. And let's see, the third Pythagorean triple that you guys were asked to memorize here back in Chapter 8 was a 7, 24, 25 Pythagorean triple. And that's what we're dealing with right here, a hypotenuse of 25, a long leg of 24. The short leg of 7 goes inside the triangle. And now, to figure out the actual value of H, we're going to multiply this 2 times this 7 and get that H is equal to 14 units. So again, the Pythagorean theorem would work too, but you're kind of stuck with your calculator at that point right there. This is a way you can do it without that. All right, so H is now equal to 14, and that's what we were missing right here. So 14 centimeters is going to be our height. And now that we know both the base and the height, we're ready to put all this together here. So area of a triangle is equal to, and again, I'm just going to go in order. The 1/2 right here gets multiplied by the 40 to make a 20, and the 20 times the 14 is going to get us 280, and that was a mistake right here. That wasn't centimeters, that should have been in inches, and then inches times inches is going to get us square inches for the area of that particular triangle there in black. And that, everybody, is a wrap on Chapter 10, Section 1. So give that worksheet a shot. Let's see how we do.